no? Yes or no? Tell me. है ना, ये किया था ना हम लोग ने, ठीक है चलिए एक सेकंड. So let me start once again this part. So these are the 7 crystal systems which can fill the complete solid. As we see that we have triangle, we have square, and we have rectangle in a 2D space, of which you can make some tiles, and by this type of tiles also you can fill the complete 2D space. Now in 3D we have these crystal systems. We have these crystal systems. These are 7. So in cubics you have A, which is equal to B, which is equal to C, and here alpha, it is equal to beta, it is equal to gamma, which is equal to 90 degree. Now when I go from cubic to tetragonal, then what I am doing, I'm elongating one size, right? I'm picking, see, आप इन दोनों में compare कीजिए, you can see that the height of tetragonal is higher, right? The height of tetragonal is more than the height of cubic. So what we did, we held the ceiling and we elongated it. So what we have to do, if I want to go from cubic to tetragonal, then elongate one side. Okay, अच्छा, just a disclaimer for all of you. When I say elongate ना, तो ऐसा होता नहीं है कि you can convert cubic to tetragonal. Okay, please move this away from your mind कि cubic से tetragonal हम लोग जा सकते हैं. We can't make a cubic crystal lattice a tetragonal cubic lattice. What I am saying that if you compare a cubic lattice and a tetragonal shape, I'm just comparing the shapes, cubic shape and tetragonal shape. Okay, so in cubic shape, if you increase one of the sides, then you will get tetragonal, in which you will have A will be equal to B, but B will not be equal to C, but all the angles will be equal to 90 degree. Alpha is equal to beta, it is equal to gamma, which is equal to 90 degree. Now in orthorhombic, you will elongate another. What I am doing, I am changing the length of another side, and that is why it will A will not be equal to B, it will not equal to C, but the angles are still same. Alpha is equal to beta, it is equal to gamma, which is equal to 90 degree. Is that clear? Yes or no? Please tell me. अरे हाँ या ना जल्दी बोलिए.
Yes,
Now in hexagonal you have already seen A is equal to B. Sorry, A is equal to B, but it is not equal to. But A and B, these are not equal to C. Okay, so A is equal to B, it is not equal to C, and alpha is equal to gamma. Alpha is equal to beta, which is equal to 90 degree, and gamma it is equal to 120 degree. Gamma is equal to 120 degree. Achha, in triclinic, tri means 3. All the 3 edges, all the 3 angles are in clinic. Why? Because they are not same. They are all different. So A is not equal to B. It is also not equal to C. Similarly, alpha is neither equal to beta, nor it is equal to gamma, and neither of them is equal to 90 degree. Okay, 90 degree. Then moving to rhombohedral. So rhombohedral, you will remember rhombus. So in rhombus, what happens? The A is equal to B, and sides are same in rhombus. Now, if you have a 3D rhombus, then the C side will also be same. Now, if you have a rhombus, then alpha is equal to beta. The angles are equal. And if you have a 3D, the gamma will also be equal, but this is not equal to 90 degree. Yes or no? In rhombus, this is the same, right? So you have rhombohedral, which is the 3D of rhombus. All of you clear? Yes or no?
Yes, sir.
Now,
Yes, sir.
you just need to remember monoclinic. Okay, I hope all of you can remember. You can remember tetragonal and orthorhombic from cubic structure. You have to elongate. Hexagonal, you already remember from hexagonal close packing. Triclinic, you don't have to remember, everything is wrong. And A is not equal to B, is not equal to C, alpha is not equal to beta, is not equal to gamma, is not equal to 90 degree. In monoclinic, you have to remember that all sides are unequal. A, it is not equal to B, and it is not equal to C. Sides are unequal. But if you look at the angles, the gamma and the alpha are equal. You have alpha, which is equal to gamma, which is equal to 90 degree, and beta is not equal to 90 degree. Okay, is that fine? Yes or no? Please tell me.
Yes, sir.
Okay, now you can remember what I say, that this is a logical way of remembering thing, memorizing thing. That cubic, you know about cubic, you don't have to remember about cubic. Elongate one side, then logically you will see that okay, one side will not be equal. Then move to orthorhombic, the 2 sides will not be equal. So all of the sides are different. Hexagonal we have already seen. Triclinic, you don't have to remember, everything will be unequal. Rhombohedral is like just rhombus, but in 3D. Monoclinic, you have to remember the sides are not equal, but alpha and gamma is equal to 90 degree, beta is not equal to 90 degree. The other way is that what you can do about the edge lengths, you can remember this by using a trick. The trick is you will write like this: chrome T T H. Now chrome TTH, chrome TTH. Okay, you will remember chrome TTH. What? Chrome TTH. So what will be with C? C से क्या होगा बताइए? Which crystal lattice will be there with C?
Cubic.
Cubic. Very good. With R, it will be, for R it will be
Rhombohedral.
rhombohedral. And O will be
Orthorhombic.
orthorhombic. M will be
Monoclinic.
monoclinic. Now with T and T, we have two things. We have triclinic and we have tetra. Triclinic, tetragonal. Triclinic, tetragonal. Tri and tetra. Which will come first? Tell me. Tri or tetra? Triclinic. Very good. ठीक है. So ऐसे याद रखिएगा. TT से घबराइएगा मत. Tri will come first. Then you will have tetragonal. And H will be hexagonal. Okay. And after this, what you have to, after this, you will leave the first two. Oops, sorry for that. You will leave the first two, cubic and rhombohedral, and you will leave the last two. Okay. And then you will make a 7. As you can see, I'm making a 7 like this. So can you see? I've made a 7 like this. Yes or no? Tell me. Or nahi banai, sorry.
Yes.
Yes, sir.
Okay. So now A is not equal to B. इतना ऐसे कर लीजिएगा तो आपका हो जाएगा सारा काम. ठीक है. So orthorhombic, you can see A is not equal to B is not equal to C. Monoclinic also, these are not equal. Triclinic also, it is not equal. Okay. Triclinic also not equal. Spelling हमने गलत कर दिया. Triclinic. Okay. Now next is the axial angles. So axial angles you have to remember. Okay. For cubic it will be alpha is equal to beta. It is equal to gamma. It is equal to 90 degree. Rhombohedral alpha is equal to beta. It is equal to gamma, which is not equal to 90 degree. Orthorhombic is from cubic only. That is why alpha will be equal to beta. It will be equal to gamma. It will be equal to 90 degree. Now ortho, it means 90 only. Orthorhombic, it will be all 90 degree. Now monoclinic, you have to remember alpha, it is equal to gamma. It is equal to 90 degree. But you have beta, which is not equal to 90 degree. Then you have triclinic. Now triclinic is what? Triclinic is alpha is not equal to beta. It is not equal to gamma, and these are also not equal to 90 degree. Tetragonal. So tetragonal will be what? Tetragonal will be alpha is equal to beta. It is equal to gamma. It is equal to 90 degree because it is a child of cubic, you can see. And in hexagonal, alpha is equal to beta. It is equal to 90 degree. And you have gamma, which is equal to 120 degree. Okay. Is that clear? Yes or no? Please tell me.
Yes, sir.
Now, any one of they can ask what is the cell parameter. Okay, so these are known as parameters. A, B, C's. Na? These are the parameters. A, B, C, alpha, beta, gamma. These are the parameter of a unit cell. So they can ask what is the cell parameters or cell dimensions for triclinic. Then you will have to write A is not equal to B is not equal to C. Alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Okay. So moving on. Let me erase this part. Oh, I can't. A second. Just wait, okay. No problem. So types of unit cell, there are two types: primitive and non-primitive, or centered or centered unit cells. So in primitive unit cell, all the atoms will be at the corner, and in non-primitive or centered, they will be at corners as well as other places. Okay, as well as other places. Now in non-primitive or centered, we have three types. Face centered, you already know. Body centered, you have already seen. Now there is new one, that is the end centered unit cell. Okay, this is the end centered unit cell. Now in end centered unit cell, we have seen that it is present at the corners and the center of two opposite phases. If you remember in molecular formula, when we are talking about the formula of compound, we said that there can be an atom in which we will have atoms in the alternate phases. Alternate phases में आपको याद है, we kept an atom in the ceiling and we kept an atom on the floor only, right? So this type of, so you will have atom here and you will have an atom here. So this is known as end centered. Okay, this is known as end centered. Face centered, atoms at all the corners and all the face centers. Body centered, atoms at all the corners and the body centered, and end centered will be atoms at all the corners and opposite faces and the two opposite phases. Okay, so primitive only at corner, non-primitive will be corner and other side, and in non-primitive you have three types. All of you clear? Yes or no? Please tell me. Any doubt in these three?
Sir, can you explain end centered again?
You can see this one, end centered. In end centered, you will have at all the corners. Okay, fine.
Yes.
All the corners. Okay, and center of two opposite faces. So what will be the opposite face for the ceiling? Floor. है ना? You will have one atom in the ceiling, one atom in the floor. Okay.
Yes, sir.
Or else what you can have? You can have one atom in the front wall and one atom will be at the front wall में, तो उसका opposite क्या हो जाएगा बताइए? What will be the opposite of front wall?
Back wall.
Back wall. If you have one atom in the, if you have one atom, okay, only one atom, कहीं नहीं, you don't have any other atom except for corners, and then you have one atom in the left wall, then the other atom will be at
Right.
right wall. You got it now? Yes or no?
Yes, sir.
Chaliye. Now moving on, what do we have after this? We have the Bravais lattices. Okay, the Bravais lattices. Acha. So if I go to the previous slide, so in this crystal systems were 7, and after this crystal system we talked about the type of unit cell. So we have cubic, so in cubic I can make a primitive, then I can make a what? I can make a face centered, I can make a body centered, and I can make a end centered, right? So with cubic I can make 4, right? Yes or no? Similarly, I have 7 crystal system, and out of all of these 7 crystal system, I can make 4 type of unit cell, and that will give me 28 lattices. Yes or no? That can give me 28 lattices. Now, is this calculation clear to you guys? Tell me first of all, yes or no?
Yes, sir.
है ना? So with cubic I can make primitive, face centered, body centered, end centered, and similarly with the remaining 7 I can make similar 4 type of lattices. So in total I should theoretically have 28 lattices. I should have theoretically 28 lattices, but there will be some which will be duplicates. How? What do you mean by duplicates, sir? Duplicates. Okay, duplicate means we have already seen either we have a triangular or we can have triangular or a parallelogram type of unit cell, and both of these are same. And not even these two, but this is also similar to the hexagonal in 2D. Yes or no? You have seen that yesterday?
Yes, sir.
Yes,
So
sir.
you can see that triangular, hexagon, and parallelogram, these all are same only. These are one thing only. That is why in these 28 there are some duplicates, and there are only 14 unique. Okay, only 14 are unique, and the others are duplicates. Now you are not a solid state physicist. You don't need to know what are those duplicates and what are those uniques. You just need to remember that Auguste Bravais, he did the mathematics. है ना, जो mathematics हम लोग नहीं कर रहे हैं, that was done by Auguste Bravais, and he showed that there are 14 distinct ways. Okay, now my only idea was to get you convinced that there will be duplicates. I'm not going into the detail of what and which duplicate, but there will be duplicates, and you understand how, and you can explain it to anyone else by using the 2D model, and then you can show that there can be duplicates, and that is why we only have 14 and not 20. We have only 14 distinct ways to arrange point in space. That means point means what? It means atoms only, right? It means atoms. In reality, those will be atoms. So there are 14 distinct ways. So they will be asking how many Bravais lattices are there, and you will be answering 14. Bravais lattice is how much? 14. And crystal systems is equal to how much? 7. Bravais lattices is 14 and crystal system is 7. Is that clear? Yes or no? Please tell me.
Sir.
So
Yes,
what
sir.
about
If you
edge
want to-
center?
Who is asking? Who is asking? Edge center?
Atif sir.
आतिफ 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 ओके आपने पूछ लिया तो फिर हम बता देते हैं आपको Let me see what happens if I have edge center. Nothing happened if I have edge center. What happened if I have edge center? The unit cell gets small. Can you see that? Atif?
Yes sir.
या नहीं दिखा है ना? So edge center बस ऐसे ही था वो questions के लिए रहता है. Okay, so that is why edge center is not a real thing. If you have edge center atoms na, then in reality what happens? The cubic, the unit lattice unit cells, they become smaller. That is it. Okay, you will have small unit cells. So moving on, if you want to look at these Bravais lattices, then you will have to look at the NCERT textbook. I'm not showing you guys because it is not useful for you. Okay, so आपसे कोई नहीं पूछने वाला कि इससे कितना आएगा उससे कितना आएगा, but they will ask you how many are there. Okay, how many different Bravais lattices can be present. Okay. Now after this, okay, if you remember, we have already discussed this point that each point in a lattice, and we have also said what is a crystal lattice. It is a 3D arrangement, and each point in a lattice, it will represent a, it is called a lattice point or lattice site, and each represent one atom, molecule, or a ion. That means one constituent particles, right? And lattice point, these are joined by straight line to bring out the geometry of lattice. Okay, so this is some redundant point that you don't need to remember. These two are the points that you need to remember, and these are already present in your notebook. You guys remember these 2 points? Yes or no? Tell me.
Yes sir.
है ना? No या yes? क्या बोला आपने? No. हाँ?
Yes sir.
Yes sir. No. Okay. ऐसा डरा मत दीजिए आप लोग please. Okay. Fine. Now next is, now this is some detail on how to make unit cell. So the thing is that you have to choose one word that you have to listen is the chosen. Normally the cell is chosen. Which cell? Chosen means you have options. So when I said now there can be multiple unit cells, so that is true. Even if you look at NCERT, they are using this word that is chosen. So you can choose if you have equals, right? So if you have different unit cells, then only you can choose one of those unit cells, right? So you can have many unit cells, but the one which is chosen, it should have perpendicular sides. Okay, it should have perpendicular sides. That is why this parallelogram was not chosen. We chose this one. And now one thing they have not mentioned about the coordination number, that was my observation only, that due to the coordination number which is visible in this type of unit cell, that is why we are choosing this square unit cell, but it is bit tilted. Again, you don't need to remember these things. This is just there for your understanding. ठीक है, एग्जाम में कोई नहीं पूछने वाला कैसे चूज करते हैं. Now I want you to identify which is this unit cell. बताइए. What is this unit cell?
Simple cubic.
Simple cubic. Primitive, non-primitive. Tell me.
Primitive.
Primitive unit cell. What about this one? एक ही का जवाब आएगा, है ना? अब एक आदमी बोलने लगता है, बाकी सब बैठ के तमाशा देखते हैं यहाँ पे. Please speak. जिसको आ रहा है प्लीज बोलिए माइक ऑन करके. The second one is what? The second one is
Body center.
एक ही को बोलना है बस. Body centered cubic. Primitive, non-primitive. Primitive, non. बाकी बोल ही नहीं रहे हैं, भगा देंगे आप लोग को हम क्लास से. हानिया, हिश्मा, हुजैफा, खलील, मिनाशी, सैफ and Shravya. What happened? Keep all of you turn your mic on. All of you turn the mic on. Only Saf did, हाँ? आतिफ, हानिया, नाम नहीं लेंगे ना प्लीज. हाँ जल्दी जल्दी कीजिए. हाँ please keep your phones on silent and not vibration. Okay, what is this unit cell? The third one. All of you tell me. Third one is
centered cubic.
FCC.
FCC unit cell. इंतजार में रहते हैं, बाकी कोई एक बोले फिर हम बोलते हैं. Okay, now please tell me primitive, non-primitive. Primitive or non-primitive? इंतजार में रहते हैं बाकी सब non-primitive. Okay. Similarly, this is body centered is also non-primitive. Okay. Also, I think now you can see that only 1/8 portion is present in this 1 unit cell of the corner atom. Also, you can see that only half of the face center atoms are present. Yes or not? All of you can see now?
Yes, sir.
Yes, sir.
No? Okay. Can all you also see that these two are touching each other?
Yes, sir.
Yes, sir.
Similarly, so that is why this atom is touched by this 4, then the face center of the walls, then the above face center of the above unit cell. So 4, 4, 4. That is why its coordination number was equal to 12. Okay, its coordination number was equal to 12. Fine. So you have all these slides, right? Anna, these are slides. I
Yes,
think
sir.
I shared this in
Yes,
the
sir.
last class. Okay. Now we'll be learning about imperfections in solid. We stop sharing this, and I have a different. Now, all of you see this? What is this now? Wait a second. Let me test this once. Yeah. Can all of you see this? G.
Yes, sir.
Okay, fine. So imperfections in solid. Now, whenever we are talking about imperfection, there should be a ideal system. So in ideal solid, what will be there? There will be no imperfection. That means if you start with one atom, if you start with one atom, same atom will be there. Same atom will be there. Okay, same atom will be there. Even if you go 1,000 atom later, you will have the same atom with the same line. So there is no distinction, or what you have a regular arrangement of atom. There is no deviation. So this is an ideal solid. This is ideal solid. So ideal solid, how will you define it? You will define it as the ionic crystal which has same unit cell. Same unit cell means in the all unit cell you will have the similar atom, and it is containing same lattice. Lattice means lattice points. It means atoms, no? Lattice points, atoms. Throughout the whole crystal, it is known as ideal crystal. Okay, so this is ideal crystal. Generally, these can be asked for 1 mark question. What is an ideal solid? What is an ideal crystal? Okay, so you have to remember this one word. Sorry, 1-line definition. That what will be ideal crystal? The ideal crystal will have same unit cell containing same lattice points throughout the whole crystal. Same unit cell, same lattice point throughout the whole crystal. Remember this one phrase till here. यहाँ से ऐसे याद किया कीजिए आप लोग. Okay, throughout the whole crystal. यहाँ से यहाँ तक. Same unit cell containing same lattice throughout the crystal. Now, if there is ideal, there will be some imperfections also. So if the imperfection is there, now any deviation, if you have any deviation from the completely ordered arrangement, then you will have disorder or a defect, or we call as imperfection. Imperfection. Okay, so any kind of deviation can be there. For example, if I am going from 1 atom, 2 atom, 3 atom, 4 atom, now there is a blank vacant space, there is no atom here, then I am having these atoms here. So the general length was a, but now if I go from here to here, I am having 2a distance. So in between we had one disruption, we have a disorder, we have a defect, we have an imperfection. So these kind of deviations, this leads to imperfections. Okay, so these are simple definition. These are the important ideal solid. What will be an ideal solid? Okay, what will be an ideal solid? Now, imperfection, it can be of 2 types. It can be a point defect. It means which is happening only for 1 point. That means 1 atom. So in point defect, what will be there? The deviation will be around a point or an atom. And a point and atom, they mean the same thing in lattice points or lattice crystals. Irregularities or deviation from point or from ideal arrangement around a point or an atom. Easy line to remember. Point defect will have a deviation around a point or an atom. Around a point or an atom. Then you have a line defect. Line defect, what happens? The whole line, that means a row of atom. A row of atom is deviated, it is disturbed. A complete row will be disturbed, and that is line defect. Similar definition, irregularity, that is in entire rows of lattice point. Okay, so complete entire row will be disturbed. So this is point defect and this is line defect. Easy parts to remember, yes or no? Can you remember this? Point defect and line defect. हाँ या ना जल्दी बोलिए. All of you can remember ना line defect and point defects, yes or no?
Yes, sir.
Yes, sir.
कुछ तो है नहीं. Hania, are you there in class?
Yes, sir.
I asked something. हाँ हानिया,
Yes, sir.
आपको नहीं आया समझ में
आया sir.
तो आपको रोजा लग रहा है, नहीं बोलना चाह रहे हैं आप.
नहीं sir, ऐसा नहीं है.
हाँ तो फिर स्पीक ना, क्या है हाँ? जब इफ यू आर हियर है ना, देन प्लीज स्पीक. देयर इज नो इंटरेक्शन, फिर क्या ही फायदा होगा. ठीक है, एटलीस्ट आई एम जस्ट आस्किंग यस सर नो सर क्वेश्चन, यू कैन आंसर दैट ना. फाइन. सो ऑल ऑफ यू कैन रिमेंबर राइट पॉइंट डिफेक्ट एंड लाइन डिफेक्ट, यस और नो.
Yes, sir.
अभी भी एक ही आंसर आया है.
Yes, sir.
देखिए हम ये बात बता दे रहे हैं आप लोगों
Yes,
को.
sir.
नाउ योर क्लास, जिस क्लास में बच्चे नहीं बोलते ना, देन द टीचर ऑल्सो नॉट फील सो मच एंगेज्ड. फिर कुछ पॉइंट्स रह जाते हैं. ठीक है, एंड नाउ दिस विल हैपन. आई एम नॉट सेइंग दैट आई विल इंटेंटिवली डू दैट, नो टीचर डज दैट इंटेंटिवली, बट इट हैपेंस ऑन इट्स ओन. So if you are engaging in the class, then the whole class will benefit with it. Okay, so please, when I ask a simple yes or no question, please turn the mic on, say yes sir and move on. Okay, say yes sir and move on. Now we will not be talking much about the line defect, because one reason, these are not in your syllabus. Why are these not in your syllabus? The reason is these are not very usual. Point defects are more usual. Okay, these are more usually occurring point defects. Line defects are not, and line defects are a bit difficult to understand. That is why mainly physicists, they learn about the line defects, and not not everyone learns about the line defects. Okay, so if you have specialization in solid state physics, then line defects are dealt with. But here we will be learning only about the point defects, because these are more usual. Now, causes of point defects. What are the general type of point defect that I can say? I can have two types. There will be interstitial. Now in interstitial, you can see here we have a particle that is occupying interstitial position. What does interstitial position mean? It means that let us suppose that this red atom was not present here. Okay, the red atom was not present here. If the red atom will not be present, then it is a void, right? Can all of you see that space between atoms? It is known as what? It is known as voids.
Yes, sir.
Yes, sir.
So this will be an atom, right? Now this red atom, it is occupying the interstitial side. That is, it is occupying the void. That is why it is known as interstitial defect. It is known as what? Interstitial defect, right? So this is what interstitial defect, in which a particle, it is occupying interstitial position. Interstitial position, that means void position. Now there is one thing that I want all of you to tell me. In the ideal system, in the ideal solid, these red points would not be there, because it is a defect we are studying. So these red points are there, but ideally speaking, these red points will not be there. So tell me, how many atoms would have been present in the ideal one, in the ideal solid? कितने atoms होते हैं blue के? Total how many atoms would have been there? Tell me. Total how many would be there?
Can you repeat?
How many atoms would have been there in ideal solid? This is a defected solid, na? So we have these atoms, extra atoms. So वो नहीं होते तो ideal होता, right? If they were not present, then it would have been ideal. So how many atoms would have been there in ideal? If I talk about this much region, 20 atoms, correct? There will be 20 atoms. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Okay.
Yes, sir.
Now, if I have the mass of 20 atoms, that is ideal, and I divide this by volume, I will get the density. Yes or no?
Yes,
Yes
sir.
or no?
Yes.
Achha. Now in this, we have this defected piece, right? Interstitial defect is there. And now tell me, how many atoms are there now in this defected piece?
22.
22.
22. And if I divide this by volume, I will get the density. So now you tell me which will have higher density, the ideal or the defected one?
Defected one.
Defected one will have higher density. Okay, so that is the point. So that is vacancy defect that I will discuss now. This is the point about interstitial. So first is they occupied vacant interstitial position in crystal, said to have interstitial defect, and this defect is, what does it do? It increases the density slightly. Okay. Now vacancy defect. Vacancy means we expected a blue atom here, but it is now vacant. Okay, this is not. There is no red atom or a square type of atom. It is vacant. There, what they are signifying, it is vacant. Okay, so this position is vacant, and this leads to vacancy defect. This leads to vacancy defect. अच्छा, इसमें बताइए, if there was ideal, then also it would have 20 atoms by volume, and this defected piece vacancy defect, it has 18 divided by volume. Now in this case, which will have higher density, ideal या defect wala, which will have higher density in vacancy
Ideal.
defect?
Ideal.
Ideal. Ideal will have higher. Ideal will have higher. That means in vacancy defect, what happens? The density decreases. Okay, so these are the 2 points. And this vacancy defect is also can be created by heating. Okay, by heating you can create vacancy defect. That is why it is also known as thermodynamic defect. Okay, it is also known as thermodynamic defect. Can you remember these points? Interstitial. Now the name only it suggests they are in interstitial position. Vacancy defect, the atoms are vacant, the lattice sites are vacant. Okay, these are lattice sites where the atom should be present and it is vacant. Interstitial, it increases density. Vacancy defect decreases density. Vacancy defect can also be created by heating. Is that clear? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay, just a second. Now, vacancy and interstitial defect, these are only defined for non-ionic solid. Okay. So these are not for ionic solid. We will learn right after this what are the point defects for ionic solid, but vacancy and interstitial are only for non-ionic solid. Now, when you read NCERT, you will be very much confused that you have interstitial and then vacancy, then you will have a similar type of, I will again see there are similar type of defects shown again. So please remember, why is there interstitial and vacancy? Because these are for non-ionic. There will be similar type of defects in ionic and they will have different names. Okay. So what are those? So in the point defects in ionic crystal, they are classified into 3 different types. The first is stoichiometric defect. Then in stoichiometric defect, what happens? The number of positive ions and number of negative ions are same. Ions, these are made by positive cations and negative anions. In stoichiometric defect, number of positive cations, it is equal to the number of negative ions. Okay. Now, this is a general definition. It doesn't mean that always the number will be same, but rather it means that stoichiometry is maintained. Okay. Now, how is stoichiometry maintained? You will understand only if you see when you will see stoichiometry that is getting disturbed. Okay. So right now you just remember a stoichiometric defect will have the stoichiometry will always be maintained in stoichiometric defect. Then we have non-stoichiometric defect in which you will have the stoichiometry, it will be disturbed. The stoichiometry will be disturbed. In non-stoichiometric defect, the stoichiometry is disturbed. And then we have impurity defect in which we have some other foreign atoms. Foreign atom or ion is present in the solid. Okay, so it is known as impurity. Foreign atom, that means it will be impurity. It will be impurity. Is that clear with these 3 things? Stoichiometric defect. See, I am not saying what is stoichiometric defect. I am telling what you have to remember about stoichiometric defect. Stoichiometric defect is the defect in which stoichiometry is maintained. Non-stoichiometric defect is the defect in which stoichiometry is disturbed or it is not maintained. Impurity defects are in which you have foreign atoms or ions that is present inside a ionic crystal. Is that clear? These 3 points, yes or no? Please tell me. With the name only you can remember, na? With the name only you can remember. Kya ho raha hai sab mein, theek hai? Now let us look at the stoichiometric defect. Let us look at the stoichiometric defect. Stoichiometric defect, one of those defects is something like this. It is known as Schottky defect. Now what is happening here? I will ask you one question. You have the red atoms which are Na plus and the blue atom which are Cl negative. Na is positively charged and Cl is negatively charged. So in this region, tell me which atom should have been present, positive or negative?
Positive.
Positive. Very good. Positive should be here, and here it should be. Here it should be negative. So as you can see, what is happening? If you are removing one positive, then you are removing one negative. Only because you have the formula NaCl. Okay, since you have the formula NaCl, so in Schottky defect, what will happen? If you remove one sodium, you will remove one chlorine. But please remember, if you have a solid which is MgCl2, then for each Mg, if you remove one Mg, you will be removing 2 chlorines. समझ में आ रही है बात? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Now, so this is what is meant by stoichiometry. This is what is meant by stoichiometric defect. That means the stoichiometry is maintained even when we are removing the atoms. For each Mg, we are removing 2 chlorine in MgCl2, but for each sodium, we are removing only 1 chlorine in NaCl. Now, easy way to remember is, as you can see, we are short of ions here. Yes or no? In this Schottky defects, we are short of ions. So ions got short. Ions got short. ओके अरे इस शॉर्ट का मतलब नाटा नहीं है ठीक है दिस इज नॉट डजंट मीन दैट लेंथ या हाइट कम हो गया किसी का शॉर्ट मींस यू अंडरस्टैंड लैक ऑफ ओके द लैक ऑफ आयंस ऑल ऑफ यू अंडरस्टैंड भाई इंग्लिश मीडियम पढ़ते हैं सब हाँ या ना हाँ हिश्मा खलील मीनाशी ऑल ऑफ
Yes, sir.
all of understand now what is short. Okay, so ions are getting short here in Schottky defect. Ions are getting short, you have less number of atoms. Now we have the different defect that is known as Frenkel defect. Frenkel defect. Now look at this position. What should be present here? What should be present here? Tell me.
Positive atom.
Positive sodium and positive sodium. But what has happened? The sodium has moved apart and it has gone here. So what is happening? He wants to make more friends. So what is happening? Ions get frank. Now they are getting very much frank. That is why it is Frenkel defect. वैसे नहीं है वैसे इसका नाम Frenkel है because Frenkel discovered it and its name is Schottky because Schottky discovered it. So in Frenkel defect, what happens? Ions are getting frank. And please remember. Now you guys will tell me. What do you think? Which of the ions can move easily? The positive ion, that means this positive ion or negative ion? कौन आसानी से move करेगा? Which will move easily? Tell me. Positive or negative? Positive because it is of small size and it can find a place where it can sit, right? It can find a place it can sit. That is why generally what will happen? Cation moves. In Frenkel defect, what happens? Cation moves. Okay. Cation will move. Okay, fine. अच्छा, density की बात करते हैं यहाँ पे. So what?
Sir,
जी बोलिए.
if the positive atom moves here, then won't there be repulsion?
There will be repulsion.
Okay.
There will be repulsion. Okay, so after this, let us talk about the density. So in Schottky defect, you can see that we have some atoms which are missing. That is why what will happen in Schottky defect, the density will decrease. Yes or no? Correct? Hi, Anna.
Yes, sir.
But what about Frenkel defect? What will happen in Frenkel defect? The density will decrease or increase?
It will remain the same.
Yeah, it will remain same. Density is same. Okay, but still we have got holes in both of these. Yes or not? Both of these defects, they are creating holes, right?
Yes, sir.
Yeah.
Sir.
Okay, fine. So what can happen? You can see that. Can you see that? If I have a particular kind of electric field, okay, if I have electric field, then these sodium atoms can be moved here. So yeah, right? The sodium atom can move here, right? No problem. Then there will be a hole created here. Yes or no?
Yes, sir.
Similarly, there will be some other sodium atom which can move now here. So you can see that ions can now move more easily if you have holes. Can all of you see that? Yes or no?
Yes, sir.
Yes, sir.
You can see here also what can happen. This atom can also move here, right? This atom can move here. There will be a hole here. Then what will happen? This atom will move here. There will be a hole here. So even though the atoms are moving, you can see that the hole, in reality, the atoms are moving, but what you will see is that holes is moving, right? Hole is moving. You will have hole here, you will have hole here, then you will have hole here. Now, due to this, since the ions are moving, this will facilitate the electrical conductivity, and that is why in both the cases, what will happen? The electrical conductivity will increase in Schottky defect. Schottky defect or Frenkel defect, both of them have holes, and due to this holes, what will happen? The conductivity will increase. The conductivity will increase. Is that clear? Yes or no? Tell me. About electrical conductivity. Okay, now we have also looked at density. Let us look at the further some more consequence here. Okay, now moving on. Schottky defect and Frenkel defect, we have discussed this point. This is the definition. This is about density, both of these points. Then it is about how when it is generally shown. So this is shown by ionic solid, that is for sure. which have a high coordination number and in which cations and anions are of equal sizes. That is why when you can remove both of them easily when you have similar sizes. But in Frankel defect, if you have anions larger than cation, then it will be easier for cations to move. Okay, so we have discussed this also. Then moving on, the consequences. So in consequences, we discussed the electrical conductivity of the crystal will increase. Secondly, due to the presence of holes, the density will decrease, but only of Schottky defect, the density decreases. The density decreases of Schottky defects. Then moving on, now there is a hole, right? There is a hole in crystal. And if there is a hole in crystal, that means we have less number of atoms. If we have less number of atoms, that means the lattice energy. Lattice energy means the amount of energy required to break a particular solid. The amount of energy required to break a solid will be lesser if you have holes. Okay, so that is why the presence of holes also decreases the lattice energy or the stability of crystal. Okay, so if you can break a crystal easily, that means it is not stable, and since you have less number of atoms and you have holes, then it is easier to break that thing. Now next is the electrical permeability, which is also known as the dielectric constant. You have heard of this word in physics, yes or no? Please tell me. Dielectric constant.
Yes, sir.
Okay, now since we have closeness of similar charge in Frankel defect, it tends to increase the dielectric constant in the crystal. Okay, so what happens to the dielectric constant in Frankel? The dielectric constant, it increases in the crystal system which have Frankel defect. Okay, so these are the four consequences of Schottky and Frankel defect. Schottky and Frankel defect. Okay, we have these consequences. Okay, so this is the end. Yeah, this is the end. I will share with you guys the PDF for this. Wait a second. Yeah. Please click the link. Tell me, can you see all of these slides, imperfections in solid?
Yes, sir.
What about others?
Yes, sir.
Yes.
Now, pura ka pura, I don't want to do it in PPTs. In the last class also, I did one question. No? So here also I will discuss one thing that will be engaging with you guys. Okay, na? Okay. So let me share my screen. Let me see what is there if I paste. Okay. There is one topic which is concept of nearest neighbor. Concept of nearest neighbor, and I will be saying nearest neighbor as NN from now on. Now for this, I will be talking about the nearest neighbor of different types of unit cell. One of them is simple cubic. Then we will talk about body centered cubic, and then we will be talking about the face centered cubic. Okay. So let me make those unit cell first. Then I need simple cubic and all. So for that, I will take a line. So first we will be discussing about simple cubic. So the simple cubic crystal lattice, then the distance, and then the number. How many atoms are there? Okay, the nearest neighbor, and then the next nearest neighbor, so on. So I will need the first nearest neighbor, then the second nearest neighbor, and then the third nearest neighbor. So that I will also put some lines here, and we will move it to get here. Then also let me okay. जब बीसीसी डिस्कस करेंगे तो यहाँ पे इसको लिखेंगे ना, छोड़ देते हैं, बीसीसी के लिए ये हो जाएगा. So moving on to simple cubic and first nearest neighbor. First nearest neighbor के लिए क्या करते हैं? Let us first of all take one of the corners. We have atoms only in the corner, so let me take this one corner atom. Okay, all of you can see this is one corner atom, and it is in the front, and it is the top right one, right? The front one, and in the top right, sorry, top left corner, right? Top left corner. You can also see in your room. It is in the top left corner of your front wall. Then the nearest atom will be the atoms which are present with a distance a. So these are the three atoms which will present. Yes or no? Can all of you see?
Yes, sir.
All of you can see. Okay. Now I can also say that since these are present here, then the number will be, you have the first nearest neighbor, and obviously these are a distance away, and the number will be 6, right? As coordination number. याद आया कुछ? Coordination number, these are all the atoms, these are touching each other, right? So these will be 6. So number will be, there are 6. Clear, yes or no? Please tell me.
Yes, sir.
Second nearest neighbor. Now this is important, second nearest neighbor. For second nearest neighbor, what you need to do? Your second nearest neighbor will be the nearest neighbor of your neighbor. You understood what I said? Your second nearest neighbor will be the neighbor of your nearest neighbor. है कि नहीं? नहीं. हाँ? Your, you understood. ठीक है. जो नहीं थोड़ा ध्यान दीजिए. Your second nearest neighbor will be the neighbor of your neighbor. है ना? अरे हाँ या ना? हाँ या हिश्मा क्या हुआ?
Yes, sir.
अरे इतना अच्छा सेंटेंस. The second nearest neighbor will be neighbor of your neighbor. So this will be which atom? यहाँ से गए हम अपने neighbor के घर. This is my neighbor's house. Then, right? This is one of the neighbor of my neighbor. Then another neighbor of my neighbor is this guy. है कि नहीं? Yes or no?
Yes, sir.
Yes, sir.
है ना? Right. Okay. Similarly, if you see this one atom here, then you can say that this is also one of your nearest neighbor. Yes or no? है कि नहीं? अरे घर जाइए आप.
Yes,
आप
sir.
इसके घर जाइए, है ना? इसके घर जाइएगा तो यहाँ से फिर ये nearest neighbor हो जाएगा. सही है? So how many do you have? 3. Yes or no?
Yes.
You have 3, right?
Yes, sir.
Yes, sir.
You have 3. You have 3 in one unit cell, right? You have 3 in one unit cell.
Yes, sir.
Yes, sir.
Okay. Also, these are phase diagonal distance away from you. है कि नहीं? Yes or no?
Yes.
Tell me. Okay.
Yes, sir.
यानी कि it means that if this atom is present in n phases, then it will have n number of second nearest neighbor, right? है ना?
Yes, sir.
Yes,
Right.
sir.
Let us see how many phases it is present in. So we know that it is present in 8 corners, right? It is present in 8 it is present in 8 unit cell, correct?
Yes, sir.
Okay, and in each unit cell it is connected to 3 different atoms. You can see in this unit cell it is connected to 3, and 3 of the faces, right? 3 of the faces, and each face has the contribution half, and each face is shared by 2 unit cell. So that is why it is efficiently present in 8 is a 24/2, that is equal to 12 different faces. Now, if you understand this mathematically, that is fine. किसी को देखना है तो हम दिखा भी देंगे कि that is equal to 12. It is present in 12 faces. देखना है किसी को? I will only tell you with faces, okay? ठीक है? If you want to see, then I can show you that one corner is present in 12 faces, but I will not. After that, I will not show anything. You will have to believe in the mathematics, okay? As you can see here, 8 into 3 divided by 12, divided by 2, it is equal to 12. By mathematics, I have proven that it is present in 8 different unit cell, and in each unit cell it has 3 neighbors, which is second nearest, and which are present at phase diagonal distance away. And since you have faces, that means phase contribution is half. That is why you have 8 into 3 divided by 2. Now, does anyone wants to see? नहीं किसी को देखना, चलिए. Moving on. Second nearest neighbor, the distance will be a root 2 because it is phase diagonal. The number will be 12. Okay, the number will be 12. Now, second. Then we have third nearest neighbor. Third nearest neighbor, all of you can see that. All of you can see that all of this have one neighbor, which is third nearest neighbor will be the second nearest neighbor of your neighbor and the nearest neighbor of your second nearest neighbor. Okay, so you have this atom here, and it is body diagonal away. It is body diagonal distance away from your house, है ना? From your atom. Yes or no? Can all of you see?
Yes, sir.
है ना? So distance क्या हो जाएगा? A root 3. A root 3. Now, in one unit cell, it is connected to one atom. Now, this atom is present in 8 different unit cells. That is why it will be having 8 third nearest neighbor, which will be A root 3 distance away. Fine? Yes or no? Tell me. आगे बढ़े?
Yes,
ठीक
sir.
है? तो ये याद रखिएगा. If you have distance, then there will be always 6 members, okay, away from you. If you have A root 2, then no matter what unit cell you have, simple, cubic, or BCC, or face centered, if you have A root 2, then there will be 12 members. If you have A root 3, there will be 8 members. Okay, there will be 8 members. Similarly, moving on to the BCC. So in BCC, what do we have? We have corner atoms. And then we have one atom at the body center. We have one atom at the body center, and we all know that this body center is connected. Yes or no? सबको पता है ये बात तो, है ना? All of you know that the body center is connected something like this, right?
Yes,
Yes.
है ना? These atoms are touching each other. These atoms are touching each other. 15 minutes earlier, Sharavia. You want to leave 15 minutes earlier, ना? अरे हाँ या ना बोलिए. Okay, fine, no problem. ठीक है? Now, that means the nearest neighbor of our corner atom is this atom, the body center atom. सही है? हाँ या ना? Right? Yes or no?
Yes.
Okay. Now this black distance is how much? A root 3. Body diagonal. सही है? अरे हाँ या ना? So this will be how much? A root 3 by 2. Half of the body diagonal. Yes or no? Half of the body diagonal.
Yes, sir.
Correct. Half of the body diagonal. Half of the body diagonal. Then you have first nearest neighbor. So you already know that there will be 8 because coordination number uska 8 hota hai. All of you know that, right? हाँ या ना?
Yes, sir.
Yes, sir.
Distance will be A root 3. This is new. A root 3 by 2 will be the distance. Second nearest neighbor. Second nearest neighbor कौन सा होगा आपका? Second nearest neighbor हो जाएगा आपका ये A वाला, है कि नहीं? Yes or no? You can. If you see this
Yes,
distance,
sir.
it's a root 3, it is a root 3. So it is more than a. So second nearest neighbor will be a. If you have a distance, then क्या होगा बताइए? How many number will be there? 6. सही है? अरे हाँ या ना?
Yes, sir.
Okay. Next will be, now this will be the next neighbor जो आपका face diagonal में है. Because again the body diagonal is what? The body diagonal is a root 3. But if you talk about this distance, which is along the face diagonal, it is a root 2. So a root 3 is obviously less than or nearer than a root 3. So a root 2, and the number will be how much? Tell me. 12. Right? 12. Correct? Yes or no?
Yes.
Okay, fine. अब हमको एक काम करना पड़ेगा क्योंकि हम भूल गए थे, नहीं बनाया ना हमने. Have to erase this part, this part, this part. Thank you, Shravya. Okay. So now we have the last item, that is the face-centered cubic. Okay. Face-centered cubic. Move this atom. I think now it is clear. Face-centered atoms, yes or no? Tell me. Yes or no? Okay.
Yes, sir.
So no. Okay. Now let us see the atoms that are touching each other are these atoms, right? In the face diagonal, correct? Hey, Kini?
Yes, sir.
These atoms are touching each other. So now since these atoms are touching each other, we have the black line. And if I want to see the nearest atoms, so the nearest atom will be this atom and the face center atom. Now these will be nearest, right? So let me color this something different and color this atom different, which is our nearest atom. So we have black, which is a root 2. So what will be the length of this purple one?
A root 2 by 2.
A root 2 by 2. This will be a root, sorry, a root 2 by 2. Number will be again, since it is face now, so we need face. If you need face, then you will be 12 only, है ना? Because for each of these you will need face, right? So 3 है यहाँ पे, एक यहाँ पे है देखिए, and then you are also touching this front one. Okay, so you are touching 12 different. You are touching 12 different atoms because the coordination number is also 12. You understand by this. Okay, please understand by this that coordination number is also 12. Second, what will be the second nearest neighbor? Tell me. Second nearest neighbor will be again this a distance, right? Because after this we have a root 2, which is what? A root 2, which is away, right? It is away. It is less than. It is less than. It is less than the a. Sorry, a root 2 is more than a. A root 2 is more than a. So second will be a, and the number will be 6, right? Whenever you have a, there will be 6. Is that right? A के साथ
Yes,
आपको
Yes.
there will be 6 ना? Can there be more? This is A distance away, this is A distance away, this is again A root 3. This will be further more away. Second में आपके पास, yeah, I think A will be only 6. A will be only 6. Okay, fine. Now third nearest neighbor. ठीक है, यहाँ पे देखिए आप. Look at this atom here. This is your second nearest neighbor. ठीक है, second nearest neighbor. Now tell me, आपका लग रहा होगा ऐसा, आपका दिल कर रहा होगा कि let us take this as the third nearest neighbor. Okay, you will be willing to do that, but can you just see the distance between the green atom and the red atom? What is the distance between green atom and red atom? Tell me.
A.
A.
A, है ना? It is A. It is A. But tell me, what is the distance between these two atoms? The green atom and this face center. What is
A
this
root 2
distance?
by
Tell me.
2.
A root 2 by 2. This is A root 2 by 2. Then what do you think? Which is more near? Red or the black atom which is present there? Let me take this as yellow. कौन सा नजदीक बताइए? Which is near?
Yellow atom.
Yellow atom is near,
Yellow.
है ना? So now the third nearest neighbor is what? The nearest neighbor of the second nearest neighbor. सही है ना? This is how we are
Yes,
defining, right? So third nearest neighbor will be. So what we have to do now? I will be not taking this one. ऐसा करते हैं इसको कि यहाँ से इसको हटाते हैं, थोड़ा क्लमजी हो जाएगा. Also this green को हटाते हैं यहाँ से, black ही रहने देते हैं. Let us look at our second nearest neighbor, which is this guy here. ठीक है, ये भी आपका second nearest neighbor है ना? And now let us pinpoint this yellow atom here. ठीक है, जिसका डिस्टेंस अगर हम देखेंगे यहाँ से यहाँ तक, this distance, yellow distance will be A root 2 by 2. ठीक है, all of you tell me yes or no. Now we need the distance between. Now we need the distance between these two atoms. यहाँ से यहाँ तक का. Okay. So can you? I hope you can already see a right angle triangle, है ना? You can see a right angle triangle in which you have the black atom. The black atom, it is what? The black atom is, you have this black line which is A, and then you have again this black line which is A root 2 by 2. Can all of you see that? Yes or no? Please tell me.
Yes.
है ना?
Yes,
And then
sir.
you have
Yeah.
this as hypotenuse. As hypotenuse. So if I want to calculate the distance, this will be equal to A square plus A root 2 by 2 whole square, which will be equal to A square plus 2A square divided by 4. Yes or no?
The 4 will only be for 2A square.
Sorry. Correct? Yes or no? Now it is correct.
Yes, sir.
Okay. So this will be equal to 4A square plus 2A square divided by 4. सही है? So this will be equal to how much? 6A square by 4. है ना?
Yes, sir.
अरे हाँ है ना? Okay. So this will be equal to 3 by 2 A square.
Yes, sir.
Yes, sir.
So D will be equal to root 3 by root 2. Yeah, so A root 3 by root 2. Fine. A root 3 by root 2.
Yes, sir.
Third nearest
You
neighbor
can
is
directly
A.
take as root 3 by 2.
हाँ वो कर सकते हैं. एक ही बात है. A you can take this as. लेकिन वही है मतलब you are saying A root 3 by 2 है ना? आतिफ. But उसमें दिक्कत ये हो सकता है ना, you can write this like this also. This is also A root 3 by 2, correct?
Yes, sir. But
Yes, sir.
हाँ बोलने में वही है ना? सो इसी वजह से हम उसको ऐसे नहीं लिखते, आई राइट इट एज a√3/√2. फाइन आतिफ?
Yes, sir.
ये √3/√2. ठीक है. अब दिक्कत ये है कि इस तरह के कितने होंगे, हाउ मेनी विल बी देयर, बताइए. क्या लगता है आपको कितने होंगे इस तरह के एटम्स? सो यू विल हैव दिस येलो एटम, है ना, देयर विल बी दिस येलो एटम and there will be this yellow atom. So these three are there in, these three will be there in one unit cell, correct?
Yes, sir.
Okay, this will be there in one unit cell. हाँ हाँ हुज़ैफा, बस हो गया. We just will be done after this number. ये नंबर लिख के हो जाएगा, ठीक है. So now you must be again seeing ये 24 आपको फिर दिखाना पड़ेगा. एक दिखा देंगे 24 तो हो जाएगा आई थिंक. Looking at this atom, right? We are looking at this atom, okay, and I'm focusing on only on this face, okay, only on this face. Is that fine? Yes or no? Tell me.
Yes, sir.
This back face here, यहाँ पे. Okay. Now this back face is not present in any of the 8 unit cell. Yes or no? बाकी जितने भी unit cell होंगे ना, you will make 8 unit cell out of this one corner. Now this wall, this back wall of your room, it will be not present in any of those. Yes or no? जैसे कि this left wall of yours, it is present in the adjacent room, है ना? It is present in the adjacent room. Yes or no? Tell me.
Yes, sir.
Yes.
है ना? This is present. This front wall, it is also present in the front room. है कि नहीं?
Yes, sir.
है ना? It is present. Okay, this is present. Now this ceiling that you have, ना, this ceiling that you have, it is present in the above room, जो आपके ऊपर वाले फ्लोर में है.
Yes, sir.
सही है? ठीक है. अगर आपको ध्यान हो, then these are the three atoms that we took, and we took 8 into 3/2 because you can see it is completely sharing between two rooms. All of these 3 atoms. है कि नहीं? Remember the
Yes,
first
sir.
thing that we did in simple cubic. But if you look at the yellow atom that is in the back wall, it is not being shared by any of those 8 unit cells. Yes or no? है कि नहीं? बताइए.
Yes, sir.
This
Yes,
corner,
sir.
this corner is not sharing any unit cell in which we have the yellow. So here we have yellow, and then you can also look at the floor. Okay, look at the floor, and then imagine, will the floor be shared by any of the rooms that is shared by the corner top? This top corner will not be sharing any rooms in which this yellow atom of the floor will also be present. And similarly, you will be having this right wall in which you will have yellow atom, and this right wall will also be not shared by any of those rooms, which is shared by this black corner atom. है कि नहीं?
Yes, sir.
That means 8 into 3, that is it, and hence 24, because it is not shared by any, and hence 24. Is it all fine? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Want to take screenshot or something? चलिए स्क्रीनशॉट ले लीजिए इसका.
Sir, is it possible for you to send this whiteboard?
नहीं समझ ही नहीं आया आपने क्या बोला. क्या बोला आपने?
So is it possible for you to upload this whiteboard to Drive like what you did with hydrocarbons last year?
एक पेज है. हाँ. You want all of those? हर क्लास का आतिफ चाहिए आपको.
Sorry,
जी
sir.
आतिफ. You need for all of those classes, all of these classes, जितनी भी classes हो रहे
No,
हैं.
sir. Only as for this one. Okay, actually, it's fine now. You can take screenshot.
है ना? You can take a screenshot. एक ही पेज है ना बस. Okay, guys. So that is it for today. है ना? I hope all of you have taken screenshot. Yes or no?
Yes, sir.